session 2C. And in this session, we have again 8 research papers which we are to discuss over a period of 2 hours up to 4:30. So there are some instructions which I am advised to share with all of you. So the primary of these instructions, I will not bore you as they are written in your, as you can see them on the screen as well. So the first is that there are out among all the papers in all the sessions that are happening, we have objective to select 3 best papers, and those 3 best papers will get a cash prize of rupees 5,000 along with a certificate for best paper. The important point to remember is that we have 15 minutes for each session, each not session, each presentation to each author, out of which 10 minutes are dedicated for the presentation and 5 minutes are to be kept aside for question and answer sessions. I will be having the uh, charge of sounding an alarm at 8 minutes without interrupting you. I'll sound an alarm at 8 minutes to let you know that only 2 minutes are remaining for the presentation, and then for the rest of the 5 minutes, the other participants who are present at the Google Meet will ask their questions and we shall have a discussion on your respective research presentation. So without any further delay, let me first call our today's first uh, presentation, which is to be presented by Ms. Aishwarya Naik. And the topic that she has written on is forensic investigation and analysis of landslide in Goa, a case study. So, Miss Aishwarya, would you please share
Hello.
your screen? Yes, yes,
Yes. Am I audible?
yes, ma'am, you are.
Okay.
Please, it will
So
be
I'll
very
start
great.
sharing my screen now.
Sure thing, sure.
Just give me a moment. Okay, is my screen visible to everyone? Hello.
Yes, yes, your screen is visible. Well, and you are audible as well. Please continue.
Okay. So let me start. Good afternoon to everyone attending this session. My name is Aishwarya and I'm coming from Goa. So the topic of my study was forensic investigation and analysis of landslides in Goa. It's a case study, and in this case study, majorly I have considered a site in Borim Ponda, and it's actually behind the Sai Baba temple, which has been constructed there quite years before. Alright. So in the introduction part, I have just kept it minimal with the basic knowledge of landslides, which is nothing but the subsurface movement of the soil. And occurrence of landslide is obviously, as we know, is highly dependent upon many of the human factors, as in the ones which we also contribute to due to many human interference. Along with that, there are also many environmental forces and lithology, and all of that also contribute to landslides. Then the second most important thing is population, increase in population, due to which irregular cutting and chopping of it also triggers landslides to a very large extent. Thus, it becomes the responsibility of us, the engineers out there, to properly design the town and cities so that lesser amount or lesser landslides, or to a certain extent, we can mitigate the landslide. Right. So from here, let me just start with my site. This is the site in Borim, which is in the North District of Goa. The first picture, we can see the recent, as per the year 2021, that is my site location figure A, and in the B we can see how it was in the year 2002. So as per the picture only, we can clearly see that irregular chopping and cutting of the slope was been done. Okay, the major reason for this was they wanted to construct a parking facility for the temple, and due to which they went with chopping of the slope behind it. And the problem was the chopping was not done properly, and due to which a very massive landslide was been witnessed by this site. All right. Then yes, exactly. I'll make a mention of the Google Pro software also. Google Pro software I have downloaded, or actually I have cropped these images from Google Pro software. Then using the same software, I've also generated the soil profile, the slope profile, sorry. Next is the rainfall pattern at the time of landslide in Borim. So this has been generated by CHRIS portal. This is one of the portal, authentic one, and this portal can give you the rainfall data of that particular day. You have to just specify the date and the year, and uh, as per that date, the rainfall in that particular region can be, you can get a plot of that. So it is like auto generated plot. You have to just select the area of interest and your date and time. That's it. Next is the forensic investigation, which is being done by college, and which is called Landslides. And these are some of the results which we have got. Let me just mention some of them. Soil content was around 28%. Liquid limit is 0.5 gram per cc. Liquid limit is 15.1 and 31.1 respectively. PI is 16. Specific soil classification was silty clay with intermediate plasticity. Cohesion was 15, and friction angle was 15. Okay, now the last two in the list is cohesion and friction angle. Now here what happens is, we as or we as civil engineers, we go on the site only when a landslide has taken place. So when we visited the site, the cohesion and friction angle which was obtained out of the soil sample which was collected, that has been reported in the forensic investigation. All right, so this 15 and 16.5 is that value. I have mentioning this because I know all of you all will be obviously knowing this, but I'm mentioning this because this can be a question to me later on, because I am actually dealing with the shear strength parameters of soil before landslide and after landslide. That's the only reason. All right. Now let me just move on to the methodology. Okay, in this methodology, what I have done is I have just taken chart which is given by Duncan and Stark in the year 1992, and as per this what is that chart, we can get the friction angle based upon the PI value. Now, as we can see from the forensic investigation result, PI was coming out to be 16, and that's what I have done. I have seen that my plasticity index, that is 16 value, falls in the range from 10 to 20. That means my friction angle will take a value from 25 to 30, 35. Okay, so this was the range in which the friction angle was supposed to fall. In my present analysis, I have considered my friction angle to be 25. Now, what is this analysis? What am I talking? So let me just give some light on this also. So first and foremost, I am now trying to determine the shear strength parameters, that is my C and phi, that is cohesion and friction angle, before landslide and at the time of landslide. So before, when the slope was completely stable and it was not having any the signs of failing, I want to know what is the C5 angle that time. And then when it failed, no, when it failed because of rainfall. Rainfall was also one of the triggering issues was there. So that was the reason. So I just want to find out the C5 value at the time of the failure. So this is the reason why we are using this Duncan and Stark chart. So now the question is, why forensic investigation? Then forensic investigation is giving me the PI value, that is 16, and by just using that 16 value I can find the friction angle. The C5 values which you can see here, these are your post landslide post landslide shear strength value. Actually what I'm determining is pre landslide and at the time of failure. I think I'm clear now. Okay. Then the second most important thing which I'm trying to determine is metric suction. Again, metric suction plays a very important role when we deal with unsaturated soil mechanics, and the formula for determining the same is been written down there. Okay. Now, this was actually the methodology which was been followed by me. As I have said, as we can see in the shear strength parameter chart also, the friction angle value which I have assumed was 25, which can be seen here down. And now, considering this as the friction value, I have determined the cohesion. Now, what I have done is, now, as we know, when it is pre-slide state, that means my slope has not failed yet. It is completely stable. Nothing has happened to the slope. That means the factor of safety at this particular point will be 1.5 or more than 1.5, right? So right now I know the factor of safety. I know the friction angle. All right. So I know phi and I know factor of safety. So the third unknown parameter which is remaining is cohesion. So since I know the two, I can determine cohesion. So what I have done is I have used two softwares to do the same. I have used GeoStudio, which is a limit equilibrium programmed software, and the second software which I have used is Midas GTSNS, which is an FEM based software. So what I have done is I have randomly chosen the value of cohesion, and for a I have entered the value 25 of friction angle, and then a random value of cohesion was selected. The program was factor of safety generated. So in my case, I got I was working on failure state. So in this part also I have done the same, but the only change is at the we have the factor of safety going from my cohesion value was 2.5. All right. Now, as I have discussed earlier, the of the soil can be calculated using the equation down there. Metric suction is nothing but UA minus or mu A minus mu W. That is your metric suction. So that has been calculated using the equation down there. I have the C5 values which can be used in the equation, and then I can get the metric suction. That's all. And then these are the results which I have generated. And the conclusion was that metric suction initially was 38.60, which decreased drastically to 5.36 due to the change in friction angle, cohesion, which was 18 to 2.5 kilonewton per meter square for a corresponding friction angle that is 25 degrees. And this was the reason for it to fail. All right. So these are the references which I have done, and that's it. Thank you. So are there any questions?
I'm sorry, ma'am. Sorry for the delay. Uh, Thank you for the presentation, ma'am. I just
Yes.
wanted to understand the reason why you assumed the value of 1.5 for the factor of safety before the failure. Like, uh, does it always follow that the factor of safety of 1.5 is ensured till the slope is not failing, or there is a probability that there may be a lack of some some initializing action, and the factor of safety was not sufficient initially as well, but because of the absence of some initiation agent or initializing agent, the slope has not failed. Have you
Exactly. Yeah. Please complete your question.
I just want to know that whether you have why have you considered the factor of safety value of 1.5 while
Okay.
estimating the
Acha, I
value of
understood that.
cohesion that you have calculated?
Yeah. So see, I'll talk about Goa since I know about Goa. What happens in Goa most of the time we see in Goa is that the slopes are completely stable throughout the year, okay, and they suddenly fail during the rainy season. And again, here also, as I have said, that parking facility, they wanted to construct a parking facility for the temple, but it didn't fail immediately after cutting and chopping off the slope. It failed when there was a heavy rainfall in Goa that particular day, on that particular day. So the triggering factor, as you have mentioned, yes, it is rainfall in this case. That's why it has been included, or we can actually club it under rainfall-induced landslide. Now the question, why have I considered it to be 1.5 or in that range? I have considered the critical case. See, if it is more than 1.5, if it is 2 or something like that, then obviously the slope is too safe, like it's over safe. So there are no possibilities of it to be failing, right? And that means the C5 value of the soil in there will be too good. But I have considered it to be 2.5, or if you see the factor of safety, which I have generated also, they are 1.54 or 1.62. So they are nearby to 1.5. So the reason was I just wanted to take the critical case. So that was the only reason and nothing else. I think I've answered your question. I don't
Yeah,
know.
yes, 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 yes. Uh, Thank you very much. Does anybody else have any question that they want to ask, Aishwarya ma'am? If not, then I would thank Aishwarya ma'am for her wonderful presentation. Short, sweet.
Thank you, sir.
Thank you. Thank you, ma'am.
Thank you, sir.
Thank you.
Yeah. Can I leave the meeting right now? Is it fine?
Sure thing, sure thing, sure thing. You can.
Yeah, yeah. Thanks a lot. Have a nice day. Bye.
Good day. Good day. Next, I would like to call Ashwin Bharat Choglezi for presenting his work on review of time and cost analysis for fabricated pre-finished volumetric construction.
Yes, sir. Thank you. Thanks a lot for short introduction. So can I share my slides, sir?
Sure, sure, sir. Please.
So is it visible now?
Not yet. Not yet.
Oh, now is it visible, sir?
No, not visible. I'm sorry.
Okay.
There is probably some glitch.
Is it visible, sir?
Yes, it is. It is now.
Uh, so I'll start the presentation. Good afternoon, respected Arnav, sir, and
Oh,
respected all other members. Today I'm going to present on review of time and cost analysis of prefabricated pre-finished volumetric construction, and the paper ID is 48. My name is Ashwin Sogle and my group member is Professor Onkar Chote sir. So before starting, I'll give the overview of the project, overview of the presentation. So we'll start with the like after World War II, there was a huge demand for housing, and at that instant, the prefabricated system came into picture, limelight, and people rather than constructing the building prefer to manufacture them. But after that, Ppvc has lost its impact. Prefabrication system has lost its impact. So I have have written a review paper on the similar lines, which is like similar technology, which is known as Ppvc. And in this review paper, I try to explain the construction process of the Ppvc technology, the feasibility of Ppvc technology over the conventional construction method in terms of time and cost parameter. And third, but not the least is I have gone through various case studies in order to get the overview of these technology. So starting to the presentation, there are three things which had resulted For the emergence of PPVC, first is the productivity. Over the years, the economical dominant construction industry has successfully completed mega projects by using conventional construction techniques. But according to the research conducted by McKinsey, an annual rise in the productivity rate for last 20 years is just only 1%. And apart from that, we had a COVID pandemic situation which had further abated the evolution of our industry. So this had resulted in cost and time overrun of the project, and also we are facing labor shortage problems. Now, coming to the second point is the demand. Every year, talking about the Indian context, we require 6 lakh urban houses, but currently we are able to fulfill 2 lakhs houses. So this had resulted in growth of slum areas and unhygienic living conditions. According to the report Brick by Brick, by 2030, the Indian urban population will rise by 6%. So there will be a requirement of around 25 million houses. So if we break it down in simple terms, it is around like 10,000 houses which are to be constructed every day. So on one hand, we have the productivity. On other hand, we have the demand, huge demand for construction, basically for residential projects. So in order that PPVC has a potential to overcome this both the problems, and considering the potential of PPVC, the government of various countries are taking an initiative. Like Singapore in 2010 made it mandatory to construct 35% of the total public residential building using PPVC technology. Recently, Government of India in 2019 conducted Global Housing Technology Challenge, under which six set of technologies were shortlisted, out of which the first set of technology is PPVC. So, what does basically PPVC means, or what is the construction technique of Ppvc? So basically what we do in Ppvc, we manufacture the standardized module in a factory, and we transport it to the site and install it according to the design on the on-site constructed foundation. Talking about the types of PPVC, there are two types of PPVC based on the materials, that is concrete PPVC and steel PPVC. In concrete PPVC, the load is transferred through the walls. In steel, the load is transferred through the steel columns and beams. The weight of the concrete PPVC ranges between 20 to 35 tons, whereas in steel, it ranges between 15 to 20 tons. Talking about the construction process, there are four stages of construction process, which are designing, manufacturing, transportation, and installation. Transportation is further, designing is further broken down into three aspects, that is architecture, then structural, and then MEP. So architecture, we need to modularize the architectural plan so that we get the standardized module size, so it is easy to manufacture. In structure, we need to consider the joineries between the two modules. And in MEP, the MEP should be integrated before manufacturing the modules, and should also be integrated uh, considering the architectural and structural aspects. So, in designing stage, softwares like BIM plays an important role. And one of the important thing is we need to have a clear idea about the stakeholders and the person who are involved in the project. If we, it gets easy to reduce the error and make the construction process efficient. Second is the manufacturing. The manufacturing is basically done in a factory environment, and in concrete PPVC module, the molds are used to manufacture the modules, whereas in steel, uh, it is generally based on fabrication of members. Talking about the transportation plan is created considering the quality of road, turning radius of the road, the slope gradient of the road. Apart from that, we also consider the clear height below the bridges. So, in order to avoid the problems during transportation stage, and last is the installation, which we do according to the design, as I said earlier. So, this process works on the principle of just in time. So, as I said earlier, we'll compare the PPVC technology with the conventional construction method based on the time aspect. So here, one research was conducted, which was published in McKinsey. So in that, they have considered a example of a building which was constructed in 24 months using a traditional construction method. So if you see in this image, the planning and designing stage, foundation, on-site construction, and the final, that is construction overrun, are both are the activities which are dependent on their predecessor, except planning and designing. But if you see the 3D volumetric, that is PPVC construction process, the foundation, the foundation on site, that is our substructure, and the off-site manufacturing of superstructure are the parallel activities, which makes a major impact in terms of time. And we get a reduction of 20 to 50% time compared to the conventional construction method. Coming to the next slide, we are comparing PPVC to the conventional construction method based on the cost aspect. So uh, here the on-site labors are reduced. If you see in the construction phase, there is a major variations we see in the on-site labor construction. That is reduction by 10 to 25%. But here the offsite, that is the yes, so uh, so through this process we come to know about, like, we get up to like 20% reduction in cost. And according to one research, the construction cost of this modular system is around 800 to 850 rupees per square feet, compared to that of conventional, which is higher, 1100 to 1150. Talking about the advantages, as most of the process is based on manufacturing, so it provides better quality, better accuracy, higher accuracy, less labors are required, large flexibility is there, and it reduces material waste by 40%. Limitations, there are, we cannot produce any organic forms using this technology. There are transportation size limit due to transportation. So the module size should be restricted. In terms of height, it should be nearly about 3 meters, and in terms of width, it should be around 3.4 meters. Talking about the Indian case studies, Tata Neu Boiser 2 project was the first ever project which was constructed using this technology in 2016. The observations were, it had it was a 80% faster construction process, 50% lesser materials and labors, then 90% reduction in waste. Second is the Lighthouse project, which is constructed under Pradhan Mantri Awas Yojana scheme. It consists of 7 blocks of G plus 8-story residential building having nearly about 1,000 apartments. This is the international case study. So here, this building is already constructed with conventional construction method, but for renovation purpose, the PPVC technology was being considered, and we observed that in this we get like 30 to 50% time reduction, and nearly about 11 to 19% of cost reduction. These are some other examples which are on similar lines. And basically, coming to the conclusion, uh, PPVC has a potential of in order in terms of in order to fulfill the demand, as well as in order to increase, it has a better productivity rate. So considering the requirement of the future, PPVC is the best suitable technology which we can practice in our construction industry. So thank you, sir. Thank you so much.
Thank you very much, Ashwinji, for a good overview on the PPVC construction techniques. Um, the work that you have conducted, you say that you have increased the labor productivity, improved upon the labor productivity as well. However, the time consumption of the overall project has also, in fact, not however, the time consumption of the overall project has also reduced. So, why is it that we do not see? What do you think are the drawbacks of the PPVC construction techniques?
So first
Can
of
you see
all,
any limitations there?
yes, sir. The
What are
basically
the
design constraint. First is the sir. If the it can be applicable when the modules are repetitive. Like if we
yes?
say a residential building has a repetitive, like the design is same for each floor, right? So most of the things remain constant. Even the structural design IPAR remains constant. So, but when a client require a unique building in such during such situation, it cannot be like applicable.
So you suggest
Second
that
thing
it
is,
is good. Yeah. Okay. Yes. Please continue.
yes, sir, it is best suitable for like affordable housing schemes, sir.
Okay. So that is what
Yeah,
I was going to say. That it finds its application mostly in mass housing projects, as well
yeah,
as for
mass housing,
construction of,
even
as
it
well
is
as for.
applicable in hostel projects.
Yes,
Yeah,
housing is housing, not resident, not essentially the housing of anything. Plus, the industrial industrial structures can be very well made of PPVC.
sure, sir.
Thank you for the informative session, Dr.
Any
Pankaj.
other
If you have
questions
any
from anyone?
questions,
Yes, Mr. Ashwin, I have a question. As you said,
Yes, sir.
whenever we are going for PPVC technique, there is considerable reduction in time as well as in cost, right?
Yes, sir.
But whenever we are going for locally available sustainable material also, sometimes we are getting more reduction in cost. Likewise, in between 30% to 60%. So,
Yes,
what
sir.
do you think?
So, like, I'm
And
considering the
if
broader picture currently. Like,
if I'm
we
if
have
I'm
a
going
huge
for
demand.
if I'm
Yes, sir.
going for composites also, in that case also I am getting considerable reduction in cost around 20%. That is also same. So why I am looking for same kind of structure instead of making different kind of structure in mass housing also, as you are discussing.
Sure, sir. I totally agree with you. But considering the future requirement, we do not have much amount of time to construct each and every building, and like ideally. So rather than constructing, we are focusing on the manufacturing part. And recently, talking about the efficiency or the cost aspect, government of India had has provides a grant if we use these technologies. So considering the low cost housing aspect, this is applicable. But as long as it depends upon the local available material, this is not an efficient method to practice, I believe.
Okay, thank you.
Sure, sir.
Any question from audience?
okay. Thank you, Ashwin sir. Thank you very much for
Sure, sir.
your
Thank you
presentation.
very much.
Uh, I would like to request Mr. Vignesh Kumar if he is present here. No, he is not.
Yes, sir. Sir, excuse me, sir. This is
Oh,
Dr. Soundara. I'm one of the authors of that paper.
okay.
Actually, he
Yes,
could
ma'am. I'm
not
sorry.
present. Yeah. So, shall I present now, sir?
Please, ma'am. Please,
Yeah.
please,
Thank you,
please go
sir.
ahead.
Hope my screen is visible. Is it correct, sir?
Yes, ma'am. It is. It is
Thank you.
visible.
Yeah. One and all present here. Very warm. Good afternoon to one and all. So the topic is the geotechnical characterization of sugarcane, bagasse, biochar, amended landfill cover soil. So myself, Saundara, and my co-authors are Vignesh Kumar, Raveen, Ranjit, and Naveen Raj. We are from Banariaman Institute of Technology, Erode. The paper ID is 077. This is my outline of presentation today. start with introduction, then materials used. It's basically an experimental oriented paper. So materials used, tests done, and results and discussion and conclusions with references. So biochar is nothing but a solid carbonaceous material which is formed by after the pyrolysis of the biomass. The biomass could be of any variety. So based on the type of biomass, normally the biochar characteristics may vary. And there are different applications in which the biochar can be used, like carbon sequestration, biofuels usage, solid waste management, and as a plant organizer, and used as an absorbent also. So based on these characteristics, we thought we can utilize this biochar in our geo-environmental applications. So normally we dump the solid wastes. Normally we require a landfill to dump the solid wastes in an engineered manner. So this is basically a landfill. The landfill has major three components. One is the liner and the filling waste material dumping storage place and the cover. So I'm thinking of here using the biochar mixed natural soil as a cover material. So there are some research studies which are using the biochar as a landfill cover material in association with the natural soil in order to reduce the methane absorption. So they will promote the methane absorption. So in that case, we can prevent the landfill gas emissions. So here, if you use the biochar related soil here, then the geotechnical aspects also should be taken care of. So those things I have addressed in this paper. So the materials which I have used, first one is the natural soil, which is collected in the campus itself. So this is the particle size distribution of the natural soil with a coarse fraction of 67 percentage and fine fraction of 33. So in that we classify the soil as a silty sand as per IS code and provision, and the specific gravity is 2.67. And we have done the atomic limits since we have some plasticity in the soil, and the liquid limit is 30 percentage and plastic limit is 24. And based on the Proctor compaction test, that is the light compaction test, we have done, and this is the maximum dry density value of 1.92 gram per cc and optimum moisture content of 11 percentage. So this is about the natural soil characteristics. And with regard to the biochar, we chose the sugar cane as the biomass, since this is the area where we have sugar mills around us, so we can collect the sugar cane bagasse from them. And we pyrolysis this sugarcane bagasse at 350 degrees Celsius within the lab itself, and for about 2 hours, then we made this biochar. Actually, this biochar is crushed and received through 2-mmC and used for the purpose. And the biochar is mixed in different proportions with the natural soil, about 5, 10, 15 percentage by weight of the soil. So initially, the light compaction tests, that is the Proctor compaction tests, were done, and we found the OMC and gamma D max for all the proportions. And based on that, we have conducted the direct shear test as a placement of 95% of maximum dry density as a placement condition corresponding to the moisture content in the compaction curve. And the consolidation test also done for the same placement condition which are used for the direct shear test. So for all the proportions, we have done the Proctor, direct shear and consolidation tests. So this is the results and discussion about the compaction characteristics. This is for the soil alone. For soil alone, we could get a maximum dry density value of around 1.92 and a OMC of 11. And upon increasing the biochar, it's a porous material and it could have take up more water in it, so the YMC could be readily higher when compared to the soil alone, and it is around 15, 21, 24 for different percentages of biochar. And the MDD also reducing because the biochar is a porous material and it is having a lesser unit weight when compared to soil, so it is decreasing. The next aspect is the soil shear strength. So we have compacted the soil in the shear box with the initial conditions of 95% of maximum dry density corresponding to the moisture content from the compaction curve. So these are the values which are obtained using the direct shear test, the peak shear stress value which is plotted against the normal stress. We have done for three normal stress cases 50, 100 and 150 kPa with a strain rate of 1.25 mm per minute. So based on these graphs we have obtained the cohesion and angle of internal friction values for different percentages of biochar mixed soil. So the C and phi values are proportionally increased with the increase in the percentage of biochar mixing. Similarly, we have conducted the consolidation characteristics because in order to get the settlement analysis of the biochar mixed soil, and this is the CV value, which is the coefficient of consolidation, which is a very important parameter in analyzing the rate of consolidation of the soil. So by increasing the consolidation pressure, the CV value also get um, the CV value normally get decreased upon increasing consolidation pressure, but upon increasing the percentage of biochar, the CV value gets increased. This shows that upon increasing the biochar content, the rate of consolidation could be higher in progress. So based on these test results, these are the main conclusions what we have arrived. The values of maximum dry density and optimum moisture content of soil are changing upon the addition of the sugarcane bagasse biochar, and the MDD values are decreasing and OMC values are increasing upon increasing the percentage of biochar. About 23 percentage of reduction in MDD values and 24 percentage of increase in OMC are noted. Obviously, the reduction in MDD values could not be compared with the soil shear strength, but here, in order to have a landslide problem, we should have to focus on the factor of safety of the slopes. So with that, if you compare, then the reduction in the MDD value could also favor the situation of increasing the factor of safety. So in that manner, it could help. And the sugarcane bagasse biochar tends to enhance the undrained shear strength parameters of the soil, that is proved by the direct shear test. About 35 percentage increase in cohesion and 33 percentage increase in angle of internal friction, which is also observed for the maximum percentage of addition, that is 15 percentage amendment. And the increase in CV value is also noted with incremental percentage addition of SCB, and about 75 percentage increase in CV value for the consolidation pressure of 100 kPa is observed for the maximum percentage increment of 15 percentage. So these are the main conclusions. It's basically a small study when compared to when the aim of the thing is we can utilize the biochar in geo-environmental aspect, and these are the studies which are the initial stage where we can conclude with we can go ahead with the further experimental analysis. Thank you, sir, for listening. So these are the references. Thank you so much. Any questions, please?
Thank you, ma'am. Thanks a lot for the presentation. How I have a very small question.
Yes,
Have
sir.
you analyzed the, like, when you are the bagasse is being converted, you have burnt the bagasse, na? So
It's not burning, it's a controlled without air, it is the pyrolysis. So we have done pyrolysis and we obtained the biochar
the after
without oxygen.
pyrolysis,
Yeah, yes, sir.
after pyrolysis, have you checked, because bagasse by itself contains a lot of calorific value. Excuse me. The
Yes, sir.
calorific value of bagasse as such is very high. It can
Definitely.
be, matlab, there are, I have read researches where people are now using it as a fuel in uh, uh, industries
Definitely.
for the calorific value of the bagasse after pyrolysis, have you considered what is the value? Have you checked it?
No, sir, that I didn't check, but
I, what do you think happens to it? I just need an idea from your side because I'm not able to comprehend. Matlab, uh, is it like does the calorific value remains the same, or it decreases after pyrolysis, or it increases further? Because if it increases further, it becomes pretty volatile as a there is the
Mm.
possibility of it catching fire in itself. So
No, no, it's what to say. It won't get fired because it's without the oxygen. So the
no, no,
absence of
not
oxygen.
after
Yeah.
the landfill as
Okay,
such.
okay. Okay,
Uh,
after mixing. Okay.
yes, I want to know the
When we
end.
utilize this one. Okay, okay.
Yes, upon utilization, the final
Yeah,
result
yeah.
might have a
Okay.
calorific value of
Since
its own.
methane is also there, so it could
Exactly.
cause, yeah. Yeah, yes, sir. In that manner, I didn't think. So definitely I will think on it, sir.
So
Uh,
this is a because Bagas I
yeah,
feel
it's a
is
valid
one of
point.
the.
Yes, sir.
So anyways, if anybody else has any questions, please you can ask.
Ma'am, I also have a small question.
Sir,
On slide number 7, when we are representing optimal moisture content and maximum dry density curve,
yes,
at
sir.
some point,
Yes, sir.
there is a change in gradient also visible.
Okay, sir. It's
For
the
any, like,
gradient. Okay.
gradient only.
Mm. So first initially it will increase and then decrease. So we were talking
No,
about the decreasing
no,
gradient.
in
Yeah.
yeah, decreasing gradient
Yeah, yeah.
in
That
5%, 10%, and 15%.
yeah. That may be due to the porous nature of biochar that can easily compress upon the removal of the air or water. So that could be the reason, sir, because
But if I,
that may have happened. Yes, sir.
but if I'm not wrong, at 2 points, like with after maximum dye density, there is
Yes,
two
sir.
point in your curve, but in both 2 points, likewise at one point it is um, mild decreasing, and at second point it is sharp decreasing kind of nature. Nature is
Okay.
also not same.
Okay, sir. I will go through it, sir. Definitely. Yes.
Okay, thank you.
Thank you, sir.
Thank you, thank you, ma'am.
Thank you, sir.
Thanks a
Thank you,
lot.
sir.
Thanks a lot. I would like to call our next speaker, Mr. Kunal Ghosh. The topic of his work that he has conducted is concrete filled cold form steel tube column, a case study. So, Mr. Kunal Ghosh.
Hello.
Yes,
Am I audible, sir?
yes, sir, you are.
Should I share?
Please, please.
Okay. Is it visible, sir?
Yes, it is now.
Okay. Good afternoon, everyone. My name is Kunal Ghosh, representing Civil Engineering Department of NIT Durgapur. Today, I am here to give a PowerPoint presentation on concrete fill cold from steel tube column, a case study, paper ID 263. These are the following topics which I will discuss in my presentations. At first, introduction. Strengthening a structural member is very much important as a
Sir,
civil engineer.
Kunal, sir, your slides are not changing. I think you have shared.
Slide is
There
not
is
changing.
some. Yes.
Is it changing now, sir?
No, I think I have you. Are you reading out of? Yes, it has changed now. Thank you.
Okay, so I can't go to the slide sharing mode. It is not showing, I think.
It
So,
will. If you'll come back to Google Meet, keeping the slide sharing mode on.
okay.
Uh,
Oh,
Come back to Google Meet and press the present button and select the full screen view. Then
oh,
it will happen.
uh, can you assist me again, sir? I came
Let
back
me
to.
let me share my screen and let me show
Okay,
you.
okay, okay, okay.
So I hope all of you can see my screen right now. Yes.
Yes, sir.
So what we have to do is you have to just go to the PowerPoint
Hmm.
and press F5. This will start your presentation in a full screen mode. Can you all see my screen right now?
Yes, yes.
But I have to press Alt Tab now and come back to Google Meet,
Hmm.
click on Present button, and once I do that, I have to select the window which is the full screen view now. Could you understand this?
At first, I have to go to share and share the entire screen, I think.
No. You don't do that. You just
Okay.
open your PowerPoint
Yes, sir.
and you just open the PowerPoint PPT
Yes.
and press F5 there.
Okay.
Once it is on in your full screen mode,
Huh.
you press Alt and Tab together on your keyboard,
Okay.
Alt Tab,
Okay.
and go to the Google Chrome where Google Meet is working,
Okay.
and then click on Present button on Google Meet. When you will click on Present, you will see two PowerPoints now.
Okay.
One will be the full screen version, other will be a PPT only.
Okay.
So the full screen version is what you have to select.
Okay. 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 I understand. Okay.
Okay.
Should I start, sir?
G, please start.
Now, sir. Is it visible, sir? Is it visible, sir?
Yes, it is now. It is.
Is it changing?
Yes, it is changing.
Okay, sir. I'm studying again.
Hmm.
Good afternoon, everyone. My name is Kunal Ghosh, representing Civil Engineering of National Institute of Technology, Durgapur. Today, I am here to present a PowerPoint presentation on concrete fill cold from steel tube column, a case study, paper ID 263. These are the topics which I will discuss in my presentation. At first, introduction. Strengthening of structural member is very much important as a civil engineer. Column is one of the important structural member. There are many processes of improving the structural performance. Among that, confining column is one of the main process. Example, PVC confining, steel jacketing, etc. In this paper, in this presentation, I will represent a case study on concrete fill cold form steel tube column. At first, now, literature survey. To know the effect of different parameters on a column, some literature were studied. These are the main remarks which I have found. In the left side, the paper author's name, and in the bottom of the column, there is the parameters, and on the right side, the remarks. When the authors considered the concrete grade, the main outcomes were increase in concrete grade result in increase in load carrying capacity and stress concentration, but decrease in ductility. When the authors concentrate on section of column, circular column gave much more ductility than other sections like rectangular, square, and hexagonal section. Rectangular and square columns carries much more load. Next. When the authors considered the parameter length of column, increasing in length leads to flexural failure where small length column fail due to crushing of concrete. When they consider confining steel thickness, if the thickness increases, the confining effect decreases. Increase in steel thickness leads to decrease in local buckling failure too. After that, after studying the parameters mentioned above, previous slide, literature some gaps were found, which is an important factor to be studied. The gaps are of failure mode, load carrying capacity, and ductility index of hexagonal section with respect to change in length is still to be evaluated and is still to be compared with circular, square, and rectangular section. So object of my presentation paper is a case study is done on hexagonal section taking the parameters as concrete grade and length, and evaluate with three different codes: European Code 4, BT Standard 5400, and AISC 2010. Some theoretical investigation is done to understand the accuracy of work and compare it with the standard code. Three different codes were used, as I mentioned: European Code 4, clause number 6.33, British Standard 5400, clause number 11.1.4, and AISC 2010, clause number I21B. After that, the material and section properties were taken from the literature, which is referred in the reference page in the number 1 spot. The material, the concrete grade used was M25 and M35 with Poisson ratio 0.18, and confining material, cold form steel, was used with yield strength of 255 and ultimate strength of 370. Analytical investigation was followed by the footsteps of the paper, which is mentioned in above. The paper is in the reference slide in the number 1 spot. Software was used was Abacus 2017. Concrete was modeled with solid deformable C3D8R element type, and steel was hollow section with element type of S4R. Other programs were general contact with penalty 0.3 was used, and displacement type loading was used for it. After that, result and discussion. To evaluate the work, the study of literature, a compare graph is plotted. In the left side, we can see the M25 concrete model, and in the right side, we can see M35 concrete model, where the blue line represent the literature graph which is given in the literature, and the red line represent the analytical model graph which I have prepared through Abacus. And we can see that it is almost identical with the very less standard deviation. In this page, I will represent the often result and compare it. In the table number 1, the maximum stress concentration and confining effect is shown here, where I have used the nomenclature HM25PCL1. The meaning of this: H represents hexagonal, M25 is a mixed grade, PC represents plain concrete, and L1 represents 400 millimeter length column, and L2 represents 800 millimeter length column. From the left side, the second number column represents the confined column stress concentration, and from the left side, the fourth column represents the column without confinement, the control column. And in the table 2, the ductility index is presented. In the right side, the first graph represents the M25 concrete model with stress strain curve, and second one represents M35 concrete model with the stress strain curve. In this slide, I will represent the load carrying capacity compared with the standard code. Every load carrying capacity of every code and the concrete model is presented here, and we can see that the standard deviation in the AISC code is much more lesser than the compared with other codes. So the AISC code is much more acceptable than other codes over here. After the conclusion, for specimen with 400 millimeter height, it was observed that it was failed due to core concrete crushing, not buckling, local buckling of steel confinement. But for 800 millimeter column, it was observed that the core concrete failed due to crushing, and the confining steel also failed due to local buckling. Higher grade of infill concrete showed higher stress concentration but lower confinement effect. Load carrying capacity determined by AISC is much more acceptable. Future scope: from the above mentioned work, it is still some leftover is done which can be studied in future. That is the confinement thickness, presence of reinforcement, different loading conditions, etc. These are the reference which I have gone through for my work. Thank you everyone. Have a nice day.
Okay, thank you, Kunal sir, very much. The podium is open for questions from the audience. If anybody has any questions, please. Dr. Pankaj.
Yes, Kunal.
Yes, sir.
If I'm looking into the title, your title of presentation was it is concrete filled cold form steel tube column,
Yes, sir.
right?
Yes. Yes, sir.
But here you discuss only property related to concrete only, if I'm not wrong.
In the property slide, I have mentioned that the those properties I have mentioned, those are cold form steel properties, and it was taken from a literature which I have mentioned in the reference slide.
Okay. So have you consider plasticity in concrete and steel also? Oh,
Yes, yes, yes. I have considered that.
so,
Actually, in the modeling process, I have considered concrete damage plasticity model.
but I think there is two model available. One is concrete damage plasticity, and second
Yes,
one
sir.
is concrete cement cracking. So,
Yes,
as in your case, you applied only static loading
yes, sir.
over the specimen.
Yes, sir.
So, which one is more suitable? Concrete damage plasticity model or concrete cement cracking model?
No, sir, cracking model is not suitable for this case. Actually, the literature I have gone through, they followed this pattern that they have followed damage plasticity model. So I just followed their footsteps and gone through towards that.
Okay. At one point, you mentioned that for concrete, you took C3D8R
Yes, sir.
type of element.
Yes, yes.
So, can you define that
Yes,
particular element?
see, is actually in finite element we divide every model into a small pieces, and Abacus has their own programming of those models. When we model concrete, it takes the small model as a brick model. So brick model is represented by that name, and after that I have mentioned that S43 something like that for hollow steel section. So they consider hollow steel like that. Actually, degree of freedom is dependent on that model type, and for concrete case that model is much more suitable than others.
No, I am talking about element only.
Yes, 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 that element I have mentioned C3D48. Actually,
C3D8R it is.
C3D8R. Yes, actually that represent a brick element, and those element is suitable for concrete modeling.
So, if I'm looking into your specimen size, it is the length is 400 mm to 800 mm, right?
Yes, two specimens are available, 400 and
So,
800.
but if I'm looking into the practical applications, there is no such kind of columns available. Like,
No, 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 no.
so you go for any model, or
Yes, actually, sir,
you have considered any scaling factor for that, or
no, 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 no scaling factor was done. Actually, we had to do a experimental work on that to validate, but due to COVID, the experimental did not happen. So we considered these two model to for the experimental. Uh, Actually, in our college, the facility for 1200 millimeter was available, but for 400 and 800, it was much more easier to experiment. That's why I have considered 400 and 800 for future experimental approach.
okay.
I have a question to Kunal,
Yes, sir.
sir.
Yes, sir.
I just please refresh the memory that 400 and 800 are the two lengths, but what are the cross sectional dimensions of your columns?
150 outer to
150
outer edge.
outer to
Yes,
outer edge. So the
yes,
slenderness ratio in the first case and in the second case
yes, sir.
was of what order? None.
What?
Both of them qualify as stocky. है ना? They
Yes,
are
sir.
both of the sections are not slender.
Yes, sir.
So if we resort to the classical Euler-Bernoulli approach,
Yes, sir.
even without conducting the finite element analysis, I could come up with what you just reported after so much of analysis on abacus. You
Yes, sir.
you conducted the analysis and you found out that the concrete at a particular section is crushing and the local buckling at the same location is happening in a cold form steel sections.
Yes,
Yes.
sir. Yes, yes, sir.
But that result did not require detailed finite element investigation. You could say all those things on the basis of Euler's buckling theory as well. Why did you conduct this research?
Actually, sir, the research is not limited towards these two sections only. As I have mentioned, that I have a future scope of comparing these things with other sections as well. So, I had prepared this to compare with.
Have you designed the experiments for that as well?
Yes, 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 yes.
What are the sections? What are the geometrical properties of the various cross sections that you have selected, like the length
Uh,
and the cross sections?
Actually, I will keep the length same and change the cross section type,
Okay.
and keep the least lateral dimension 150 and use other two or three different sections.
You will make it still is bulkier.
No, 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 not bulkier. Actually, I will follow the pattern.
Least
The
lateral dimension
Yes,
would be 150. You just said.
150. Yes, sir.
So slenderness ratio will be calculated on the basis of that dimension only.
Yes,
The
yes,
length
yes,
divided by least
yes,
lateral dimension.
yes.
So your result essentially will not change. What you should do is, if you are conducting this research further, you
Okay,
should consider increasing the length of the specimen rather than playing with the cross-sectional properties.
okay, sir.
Increase the length of the specimens so that you can have long column effects as well.
Yes, sir.
And when you will do that, you will understand that there will be the failure pattern will not only be limited to the crushing of concrete or the buckling of the column or the local buckling.
Yes, sir.
How? But overall buckling of the section can also be seen, of the column can also be seen. So this is my suggestion to you, that
Okay,
when you
sir. I will.
conduct or design the experiment, please take into account some sections which are much larger in length than
Yes.
800 mm.
Okay, okay, okay. I will keep it
Okay.
in my mind. Thank you, sir.
Okay. Thank you very much. Thank you. Next, next, I would like to request Mr. Neeraj Kumar Chobe. I hope he is present in the audience.
Good afternoon. Am I audible?
Yes, sir, you are. Kunal, hello. Okay, he has muted himself. Neeraj, sir, please.
Okay,
The
I'm trying to
work
present.
conducted by, let me just introduce your work.
Fine, fine.
The work conducted by Mr. Neeraj Kumar Chobe along with Dr. Arun Kumar Mishra is to evaluate the performance of warm mix asphalt containing reclaimed asphalt from the pavements.
Uh,
So,
Thank you for the introduction. Please confirm me if the slide is visible.
yes, it is. It is.
Thank you. Thank you. This is Neeraj Chaube, and I am presenting on the performance evolution of warm mix asphalt containing reclaimed asphalt pavement. As we know, India is the second largest country in the world for road network, and there are huge demand of natural aggregate for in the road construction sector. Like approximately 30,000 ton of aggregate requires for the construction of 1 kilometer of road. It means there is huge pressure on the natural resources of the road aggregate. uh, and to meet the requirement of this uh, demand, we require to utilize some of waste in the construction industry, and that is why I have used here wrap reclaimed asphalt pavement, which is obtained by removing the existing or old asphalt pavement. Wrap is obtained as a mixture of aggregate and bitumen. We are using a wrap as aggregate in this research, and the second thing is that for road construction hot mix asphalt technology is popularly executed. But recently, warm mix asphalt technology come in the existence, where the production temperature of warm mix asphalt kept lower than hot mix asphalt, and it is lowered by 17 to 15 degree Celsius. It means the technology which is used for producing warm mix asphalt is emitting less carbon, and it reduces the energy for the asphalt production. Like the production temperature is reduced by adding organic additive in warm mix asphalt, and whereas the chemical additive can increase the workability, coating and mixture. We have another technique like cold mix asphalt, where water is used to reduce the viscosity of binder, and is known as the foaming technique, which is also a type of technique used for the production of asphalt mixes. The objective of this study is that the Marshall stability and flow value will be evaluated to determine the mechanical strength of the mix, and indirect tensile strength was evaluated to determine the cracking, and the tensile strength ratio was obtained to find the temperature moisture susceptibility of the asphalt mix. These are the used material. The bitumen was used, having viscosity grade 30, VZ grade 30 bitumen, and the conventional aggregate, which is obtained from the Banda quarry, is used in this study. And reclaimed asphalt pavement were collected as demolished waste of pavement. It was collected locally. The physical properties of the used material were determined, and the result are presented in this table. We can see the first physical properties of bitumen. uh, all the uh, all the tests were conducted following the IS standard test method, and are found all the value like penetration, softening point, flash point and fire point, ductility. These value were found within the required criteria. Like physical properties of granite aggregate and physical properties of wrap aggregate was evaluated, and both were found the required criteria as specified by the MORTH. These are the selected gradation. The gradation was adopted at DBM 2 for DBM 2 as per MORTH classification. The warm mix asphalt was produced using a additive called Sesobit. It is easily available additive for producing warm mix asphalt, and the optimum bitumen content was obtained having the various mixes. Like we prepared the one mix having 100% natural aggregate and 0% wrap, and second is the 75% natural aggregate and 25% rack, and third one was the 50% aggregate and 50% wrap. The optimum bitumen content was found to be for mix 1 5.52, and for mix 2 5.35, for mix 3 5.26. It can be seen here, as we increasing the wrap content, the optimum bitumen content decreases. It decreases slightly. The Marshall test and the Marshall test and the indirect tensile strength, that is ITS, and tensile strength ratio test was conducted to evaluate the mechanical strength, cracking strength and the moisture susceptibility of the warm mix asphalt produces with inclusion of wrap in various proportion. ITS can be calculated by the equation 1, and the TSR, tensile strength ratio, can be calculated by the equation 2, where ITS condition means the sample were conditioned for 16 degree Celsius for 20 hours and 16 degree Celsius for 24 hours, and the unconditioned sample was not gone for the conditioning. These are the result of Marshall parameter. The maximum Marshall stability and flow value was observed as 0% replacement of RAP. It means when we have 100% natural aggregate, it shows the maximum stability and the flow value. The Marshall stability and flow value decreases with the increasing proportion of RAP. Although all the produced mixture with warm mix asphalt technology falls within the minimum requirement, that is 9 kilonewton for the Marshall stability and 2 to 4 for the flow value. The highest drop in the stability and flow value was observed with addition of 50% RAP in warm mix asphalt. This decrease in stability and flow value could be the result of stiffened binder due to aging effect of RAP material. The Marshall stability for different composition of RAP in warm mix asphalt can be seen in the graph. Like for 100% aggregate, it is maximum, and it reduces, and it is minimum at 50% of aggregate and 50% of RAP. These are the flow value, Marshall flow value obtained, and it is also maximum at 100% aggregate, and it is the minimum for 50% aggregate and 50% RAP. This value is obtained for the indirect tensile strength. The blue portion shows here the ITS for conditioned sample, and the orange is for unconditioned sample. Here we can see the ITS also reduces as we increases the RAP content. This can be due to the weak adhesion between the binder and aggregate, and due to the improper orientation of aggregate. The weak adhesion between the binder and aggregate is due to that we have already existing uh, bitumen surround the aggregate in RAP material, and because warm mix asphalt technology produces asphalt at lower temperature, there at lower temperature the bitumen is not able to coat properly the aggregate. That's why there is weak adhesion between binder and aggregate. And when we remove the aggregate from existing pavement, it gets the gradation finer than it was before, than it was original in the pavement. That's why here we see the improper orientation of aggregate in the sample, and that's why the ITS decreases. And this value is due is for the tensile strength ratio, which is a measure of moisture susceptibility of asphalt mix. It also decreases with the increasing content of RAP. These are the conclusion of this study. As I have already told, the optimum bitumen content of warm mix asphalt containing RAP mixes were decreases, and the incorporation of RAP in higher proportion decreases Marshall stability and flow value. However, it satisfies the minimum criteria of Marshall stability and flow value. The increasing amount of RAP causes decrease in ITS value and TSR value. The use of RAP could bestow economic advantage by reducing the consumption of conventional aggregate. However, higher content of RAP may lead to fatigue cracking of asphalt pavement, because there is not proper binding between the aggregate and the asphalt at lower temperature. Though WMA technology comes with many environment benefit, however, uh, WMA could show adverse result in terms of resistance to moisture damage and permanent deformation of pavement. These are the references. Thank you.
Thank you, Mr. Neeraj, for your presentation. It
Yeah.
was informative.
Yes.
Uh,
Thank you.
uh, what are the various factors that you considered while you thought about reclaiming the asphalt?
Like the first thing is that it is a construction waste, and this should be utilized in somewhere. That's why I used RAP. And the second thing is that RAP already contains some bitumen, Hence, it was pre-known that it will reduce the quantity of asphalt, required asphalt, and we see in the research that the optimum asphalt content reduces with the increasing content of RAP. And also it has a similar physical properties like natural aggregate. That's why it can be utilized as virgin aggregate in the pavement.
Okay, okay. Thank you very much for your time and for presenting your work, sharing your work with us.
Thank you, sir.
Anybody from the audience, if they have any question, please go ahead and present. You can ask your questions of Mr. Neeraj.
Neeraj,
Yes, sir.
uh,
Please.
I, I have a question. Like, if I'm looking into the rep on hot mix asphalt, so many research is available. I'm
Definitely,
not
sir.
I'm not aware with warm mix asphalt, but on hot mix, almost all the parameters are already covered
Yes,
by
sir.
so many researchers.
Yes,
So
sir.
if you are working on your PhD, then please look into that. So
Definitely, sir.
it is a repetitive kind of work only. Otherwise,
Definitely, sir. Actually, there is. Can I answer?
yeah, yes, yes, yes.
Actually, there are huge study on the hot mix asphalt, and warm mix asphalt is recently something new,
Hmm.
where research is going. Uh, that's why I used warm mix asphalt, and in warm mix asphalt the temperature is quite low. It's like in hot mix asphalt we require up to 175 to 180 degrees Celsius, and in warm mix asphalt we heat the asphalt and aggregate at just 100 or 110 degrees Celsius. That's why if we are reducing the temperature, there is a low carbon emission, there is a low energy consumption, and also it creates it's the surrounding is good for the working labor. They do not feel very hot or like toxic gases are not there.
So in that case, is it possible to utilize your as there is some bitumen content already available in REP, right?
Definitely, sir.
So
Yes, sir.
is it usable or not at this low temperature?
uh, it is at low temperature it is it is usable, but not we cannot replace 100%. Up to 20 or 30% we can use it.
Okay, thank you.
Thank you, sir.
Okay, thank you, Neeraj sir.
Thank you, sir.
Uh, Next, I would like to call upon Dr. Shetty for
Yes, sir.
once again for his presentation on bending deflection solution of thick beams using a third order single variable beam theory.
Okay. Sir, I will share my screen, sir.
Sure thing, sure thing.
Sir, my screen is visible. Hello.
Yes, sir, it is visible. It is visible.
Good evening, all. I am Dr. Rajesh Shetty. Now I am going to present a paper entitled Bending Deflection Solutions of Thick or Shear Deformable Beams using a simple single variable beam theory. The co-authors of this paper are Mr. Deepak S.A., Mr. Dushyant Kumar GL, and Mr. Sudhir Kinike. The objective of this work is to demonstrate the effectiveness of a simple single variable beam theory by conducting the bending analysis of thick or shear deformable rectangular beams. I will just give a brief introduction about this theory. This theory uses a single unknown function for the complete formulation of the beam, and the many equations of this single variable theory are strongly similar to those of Euler-Bernoulli beam theory, like governing differential equation, boundary conditions, and expressions for bending moment and shear forces. So this theory has a strong similarity to that of Euler-Bernoulli beam theory. So using this single variable theory, we can do the beam analysis in a similar manner as we do in case of Euler-Bernoulli beam theory. Okay. first we will discuss about the research gap. We are all familiar with the elementary beam theory or Euler-Bernoulli beam theory. This theory we have studied in your course known as mechanics of solids or mechanics of materials. So this Euler-Bernoulli beam theory can be used only for the case of slender beams, as Euler-Bernoulli beam theory only considers the bending deflection. Next, we have in this category, in case of beam theories, we have shear deformation theories. Under this, we have the first order beam theories and higher order theories. In case of first order theories, we have well-known example is that is Timoshenko beam theory. In case of Timoshenko beam theory, we have to use a shear correction factor. And next we have the higher order theories, and in case of the higher order theories we have the complex equations like multiple differential equations and multiple variables. So in this work we will discuss about a simple single variable beam theory. This is the simple single variable beam theory. This is the displacement field, equations 1 and 2. Equation 1 gives the in-plane or axial displacement, and equation 2 gives the lateral displacement. And in equations 1 and 2, we can find only one unknown variable, that is the WB. So with the help of only one variable, we can do the complete beam formulation. This is as in case of Euler-Bernoulli beam theory, because in case of Euler-Bernoulli beam theory also we have a single unknown. Next, we have in equation 3, we have the expressions for bending moment, that is mx is the bending moment and qx is the shear force. And these expressions for bending moment and shear forces, these are similar to that of Euler-Bernoulli beam theory. Next, in equation 5, we have the governing differential equation, and this is the governing differential equation of this single variable theory. And this governing differential equation is also strikingly similar to that of Euler-Bernoulli beam theory. And in this differential equation, WB is the unknown. So using this equation 5, this is a very simple equation. We can obtain the expression for WB by just by the direct integration. So if we integrate this equation and we will apply the boundary condition, we will obtain the solution for WB. And next, by using WB, by substituting in equation 2, we can obtain the total lateral deflection, that is W. Okay, next we have the this is the simply supported beam, that is the length of the beam is L and width of the beam is B and height of the beam is H. So next we have the boundary conditions. These are the equations 6 and 7 gives the equations for boundary condition, that is simply supported boundary condition. Next, in equation 8 and 9 we have the boundary conditions for the case of free end. When this is for the in case of cantilever beam, you can use this. Next, we have the clamped end, that is the boundary conditions are given by equations 10 and 11. So these are the clamped end boundary conditions. Okay, next we will discuss few illustrative examples by we are using these expressions for solving the beams with various boundary conditions. That is simply supported beam carrying a UDL. So equation 12 gives the, that is the Euler-Bernoulli beam theory solution. That is the and next in equation 13 we have the deflection expression obtained by Timoshenko beam theory. Then by equation we have the Levinson beam theory, and next we have using this present theory. So if you refer these through these four equations, on the first part we can see this is the bending part. That is similar to that of Euler-Bernoulli beam theory. This captures only the bending deflection. Here we have the bending part in the Timoshenko beam theory. Then Levinson also we have the bending part. Here also this is for the case of this present theory. So this second part, this corresponds to the shear part. Okay. This is the shear part for the Timoshenko beam theory, and this is for Levinson theory. This is for the single variable theory. So it is found that in this case all the equations 13, 14, 15 are same, and in equation 13 we have the k, that is shear coefficient, that we have to use in case of Timoshenko. In this case it is used as k is equal to 5 by 6. So in this case it is found that these three expressions are same, but we can note that in case of Timoshenko beam theory we have two equations and two variables, and in case of Levinson beam theory also we have two equations and two variables. But in the case of present theory we have only one unknown. Okay, so it is found that the equations are same. Next, we have the cantilever beam carrying a concentrate load. In this case, also this, if you refer to equation 16 to 19, the first part represents bending solution, and in equation 17, 18, 19, on the second term, it is corresponds to the shear deflection. Okay, so and it is found that in this case the Timoshenko beam theory is under predicting the deflections, or it is underestimating the deflections. Next, we have the solutions for cantilever beam carrying a uniformly distributed load. These are the solutions are given by equations 20 to 23. That is, the first part is corresponding to bending, and the second part corresponding to shear deflection. Similarly, next we have the deflection expressions for clamp beam, and okay, in all these four cases, that is, we have discussed four cases. That is, simply supported beam. Then we have the cantilever with the point load and UDL. Then we have the clamp beam with the UDL. And all these solutions are compared with the theory of elasticity solutions. So in all these theories, for example, in Euler, Bernoulli, Timoshenko, Levinson, and this single variable theory, in this case we are considering the beam as a one-dimensional structural element and doing the analysis. So these solutions can be compared with the a little bit more accurate approach, that is theory of elasticity approach. In case of theory of elasticity approach, we consider beam as a two-dimensional structural element. So we have compared all these expressions with the deflection expressions obtained by the theory of elasticity approach, and it is found that all the results are within the very less error, like 1 or 2%. Okay, now we will discuss about conclusion. So it can be what we can conclude is using this single variable theory, we can do the analysis of beams in a very simpler manner. That is, as in case of Euler-Bernoulli beam theory, because we are all familiar with the how we can do the beam analysis using Euler-Bernoulli beam theory. In the similar, as in case of Euler-Bernoulli beam theory, we can do the analysis, and also we have compared these results with the other beam theories like Timoshenko beam theory, Levinson beam theory. So the results are within the results are almost same. Okay, these are my references. Okay, so my presentation is over. Sir, any questions?
Thank you very much, Reddy sir, for your second presentation of the day. We were really startled by the zest with which you presented both the topics.
Yes.
Thank you very much.
Okay.
I would like to ask Dr. Pankaj if he has any questions, or any of the people who are attending can ask.
Yes, Rajesh sir.
Sir.
So earlier also and right now also, you are saying that the particular theory, single variable theory, is showing almost same result, or we can say very negligible error.
Yes.
So is it possible to apply this? Right now you are discussing thick beam, right?
Yes, sir. Yeah.
So whenever we are looking into the thick beam, so in that case we are considering stress variation along the thickness also.
Yeah.
Yeah. Is it possible to determine the stress variation along the thickness
Uh,
by single variable third order beam theory?
Sir, okay. Whatever theories I have mentioned, like Euler-Bernoulli beam theory, Timoshenko, Levinson, and this single variable theory. In this theory, the stress in the normal stress, or what we can call transverse normal stress, this stress component is ignored. Okay, we have the transverse shear stress. The transverse shear stress is considered, but the formulation of these theories, the transverse normal stress is ignored. That means we can't capture the through the thickness variation. That we
Variation.
can't
Right,
capture.
right.
Yeah.
But these are global theories and these are usually applicable for general problems only. But right now you are considering a specific theory. That
Yes.
is that is why.
Yes, sir.
Because if I'm comparing with previous theory and you are getting almost same result, then there
Yeah.
is no chance of improvement. So
Hello. Sir, actually, the main objectives means what we are highlighting is the simplicity of this theory. Because as I have mentioned, the whatever equation, the equations associated with this single variable theory, the equations are they are similar to those of that Euler-Bernoulli beam theory. So mainly we are focusing on the simplicity of this theory.
okay, sir.
Okay, sir.
Thank you.
Thank you.
Okay, thank you, Reddy. Thank you, Shetty sir. Thank you very much. We we have one more presentation to go. Mr. Vibhakar Kumar Singh.
Hello.
Yes, sir.
Yes, I'm audible, sir.
Yes, you are, sir.
Okay. So basically, this work is I'm co-author of this paper, sir. My guide is not present here, so I'm going to present my paper.
Okay, no issues. Please go ahead, sir.
Okay. My screen is visible, sir.
Not yet. Not yet.
My screen is visible, sir.
Not yet, Vibhakar ji. Not yet.
Okay. Okay. Now visible, sir.
Yes, it is visible now. Thank you.
Okay. Thank you, sir.
Please continue.
Good evening to all of you. I'm going to present my paper on physiomechanical and thermal performance of newly developed lightweight mud Fiscal composites for roof treatment. My paper ID is 134. I'm the co-author of this paper. So I'm going to present the outline of my presentation. First, I'm going through the solid waste, what is solid waste, an introduction. Second, what is mud Fiscal, a basic introduction. Third point is experimental program, optimization of mixed proportion, methodology. And last one is results and discussion and model testing. So first first I'm discussing the issue of solid waste generation and production in India, and the environmental issue behind this huge production of solid waste. Presently in India, about 960 million tons of solid waste generated annually, out of which only 30 million tons is organic and 290 tons are inorganic waste, which is uh, a huge number, sir. Advance in solid waste management results in alternate construction material and substitute to traditional materials such as bricks, blocks, tiles, and aggregates. So our focus is solid industry waste, solid leather waste, and my research topic is also on is solid leather waste and its utilization for making construction material. So leather industry is one of the polluting industry, as we all know in India, because it uses huge amount of water. It because it generates huge amount of solid and liquid waste also. Right now in India, more than 2,000 tanneries, with the majority in Uttar Pradesh, Maharashtra, and Tamil Nadu, which produce solid waste nearly 1 metric ton per year, which is huge number, sir. So there are different types of waste generated in leather industry. There's our buffing dust, saving dust, trimming, flashing, and blue trimming. As for now, presently in India, the situation of solid waste generation, there are several institutes where the work done in the field of leather industry waste and contribution to various institute towards it. They use buffing dust for making bricks. They use different leather industry waste for making different building materials also. Now, my topic is mud fusca. So let me introduce first what is mud fusca and introduction. A mixture of soil with agricultural waste and water behaves like a heat insulating medium when applied over the roof, wall, or houses. We all see in remote areas of India or villages, there are roof where they covered the wall or roof with mud, basically a mixture of mud with different agricultural waste. So uh, it provides very cold atmosphere inside the house uh, in hot climate, in dry climate, and so most commonly is used in hot dry regions of country, Punjabs like Uttar Pradesh, uh, and the region of low to medium rainfall. So this is the very cheap and traditional technique, sir, because there is no use of electricity for providing comfortable environment inside the house. In town, we use AC and different other mechanical devices for this purpose. But in this technique, there is no use of electricity. So we focused on, we give an idea of this traditional technique, and our research works is focusing to develop a modified Masfasca tiles with the use of leather industry waste, which is applicable over the roof. So basically, this is the topic of presentation. Right now in India, there are various other techniques also used for providing cold atmosphere inside the houses. As we see in this figure, first one is brick cover technique, where we cover all the surface of roof with bricks. But these techniques have their disadvantages also. First one is less thermal insulation, imposes unnecessary load because we cover whole surface of roof with bricks. So it imposes unnecessary load over the roof. And also bricks act as a, sometimes when roof is damaged, then they store unnecessary water. So this technique is not, there are many disadvantages of this technique. So we, in our research work, the mud fusca tiles has a better thermal insulating material having the flowing properties. It is lightweight because we use soil and leather industry waste and agricultural waste. So it is definitely lightweight, sir. So we first set the targets. Our targets for making a roof heat insulating tiles, having dimension of 300 into 50 mm. Density is 1000 to 1300 kg per meter cube. Modulus of rupture is greater than 2.5 MPa. Thermal conductivity is between 0.50 to 0.55 watts per meter Kelvin, and R value is greater than 4, and water absorption is ranges between 22 to 25%. This is according to IS code. So first we in this slide, the collection of raw materials which is used for this research work. First, we take the soil, locally available soil. Second is wheat straw, which is locally available. Third one is bagash, sugar cane industry waste, and third is crumb rubber, which is sir. In India, there are huge number of waste tire available. So right now, what we did, we just burn the tire, so it causes huge environmental problem also. So uh, rather we burn the waste tire, we use this tire for making some other material for using further using in making different types of building material. So in our case, we use crumb rubber with sizes, the crumb rubber with sizes is less than 30 micron. First, we prepare the soil. We first oven dry at 105 degrees Celsius, then sieve it through 1.18 mm, and then soil is prepared for casting. And we prepare. We not prepare crumb rubber. Definitely, sir. We purchase this from nearby industry. This is the figure of preparing my agricultural waste product for mixing, for making mixed proportion. Now comes to material characterization. We do particle size distribution, sieve analysis. Uh, this is necessary to characterize the soil, because it is necessary to using because we are going to use the soil as a binding material. So it is necessary to determine the characteristics of soil and the percentage of basically we want to know the soil nature. Is this cohesionless soil or cohesion? There is cohesion in that. So we do liquid limit test. After doing liquid limit test, and we comes to know that according to as per IS code 2115, plasticity index is for mud fusca tiles is ranges between 10 to 15%. But in our case, the soil of locally available soil is less cohesionless, so we have to add some other alternate binding material into that for making it more cohesion. So we add some portion of cement in soil. We add 6%, 8%, and 10% for cement to make the soil sample stabilized. So at last, we found that at 10%, sir, cement is enough to make the soil sample stabilized. Now, after stabilization of soil with 10% of OPC, our liquid limit is 25% and plastic limit is 14%. According to IS code 2115, for mud fusca tiles, plasticity index ranges between 10 to 15. In our case, it is 11%. So for making different mix proportion, we use different mix proportion. First is soil and cement and water. Second is cement, water, and wheat straw. Third one is cement, soil, sugarcane bagasse, and water. Uh, Soil, ordinary Portland cement, and crumb rubber and water. And soil or cement, crumb rubber, wheat straw, and water. And last one is soil, cement, crumb rubber, wheat straw, and water. Now we, in this slide, after that, after making mixed design, we want to know the amount of water needed for making the mixed proportion more consistent and workable. So we conduct flow table test for all the mixed proportion. So uh, after getting water binder ratio, the process of casting and curing is started. First is mixing of raw material. We take sieved soil, added crumb rubber, and the amount of water needed we add. And after that, we put into the casting cubes over the vibrating table and curing in curing under water because we add some cement. So we cured under the water. Some samples were not suitable for. We found that later found that some cubes were dissolved in water. So we cancel out this mixed proportion because they are not suitable for making final product, making mud first. Now we comes on result and discussion. After 7 days and 28 days, we test the results of all the cubes. So what happens, sir? Our end product is tiles, but making tiles, first we have to make check cubes, mix cubes, and check its properties, its compressive strength, its thermal conductivity. So we check by making small cubes. We found that the sample made of soil, crumb rubber, cement, and water, showing the highest results. Here we see the 13.11 MPa after 28 days. But we not choose the highest compressive strength values just because we have to see other properties also, like it is lightweight or not, or the thermal conductivity of that mixed proportion. So after analyzing all the results of compressive strength and other results, we finally choose our sample GA11, which compressive strength is for 28 days is 3.92. So actually, sir, we chooses low compressive strength here because for construction purpose, according to IS code, uh, brick more than 3 MPa we use for construction purpose according to IS code. And over the roof, when we apply the tiles over the roof, so we neglect this the load bearing phenomena, we neglect that. So we have to choose GA11, which is designed by soil, crumb rubber, cement, and water. Now we check these small cubes for thermal analyzer. We check its thermal effusivity, thermal conductivity, thermal diffusivity. Uh, Thermal effusivity is the thermal response of that specimen, sir. And thermal diffusivity is the rate of transfer of heat from one end to other end. So we choose the value of thermal effusivity and conductivity. The value of thermal effusivity is very high in the case of GA1. So we choose, and at the same time, density is also less as compared to the other mixed design. So So after finalizing the mix proportion and finalizing the mix design, we cast the final specimen of size 300 into 300 into 50 mm by same techniques through same techniques what we are using for making small cubes. The mix of GA and GA showing the following properties: lightweight, sufficient compressive strength, desirable thermal resistance, optimizing different waste also. So we developing a heat insulating tiles. At the same time, we also utilizing huge amount of waste material, which is crumb rubber, sir, and different agricultural waste also. After 28 days, we conduct the graduated hot plate method test for our tiles. So the thermal conductivity results of our tiles is 0.25 watts per meter Kelvin, which is according to IS 3792 thermal conductivity of mud fusca composites is 0.519. So in our case, this is much below than what is mentioned in IS code. So this is the finding of our research work. In this slide, we compare the class 3 brick, the traditional bricks for using heat insulating medium, and our product, sample GA1. The compressive strength in our case is 3.92. For class 3 bricks, it is 3.43. Hardness reasonably hard. Density is lower than the conventional class 3 bricks. Thermal conductivity is way lower than class 3 bricks, and heat capacity also lower than class 3 bricks. So this is the final output of our work. Thank you, sir. This is the references.
Thank you very much, Vipakarji. Uh, it is almost time, and as we missed one of the sessions in the last, one of the presentation in the last session, so what I'll do is I'll call Miss Aishwarya Thakur to present her work uh, in brief, so that we can understand what you have done and can rate your
Okay, should
work.
I close the window, sir?
Sure, Vivakarji. Thank you very much.
Okay, thank you,
Thank you
sir.
very much.
Thank you, sir.
Good afternoon, sir.
Good afternoon.
Just wait. Sir. So my slide is visible, sir.
Yes, ma'am. Your slides are visible.
Okay, sir. Okay, sir. Good afternoon to everyone. I am the presenter of this paper, and my name is Aishwarya Thakur. And the name of my paper is a review on non-destructive technique for corrosion monitoring in reinforced concrete structure. And right. These are the topic which we are going to go through during this course of this presentation. First one is introduction to corrosion, then what factor affect the corrosion, and then type of corrosion, then method for detecting the corrosion. After that, method for detecting the damage and difference between destructive and non-destructive technique, and what type of sensors, and then after that literature review, and at last conclusion. And first slide is corrosion. What What is corrosion? And corrosion is the process which we can't see visually, and until crack, or rust stain appear at the concrete surface. And corrosion is a process in which metal is exposed to the moisture, air, water for some time, a layer of oxide formed which weak the metal, and that's process called corrosion. And mostly the chloride induced corrosion is more dangerous due to its localized nature. As you can see in the figure number 1, electrochemical process for corrosion initiation. In this figure, when in this figure, when iron is come in the contact with chloride and carbon dioxide, because of this, Fe lose their 2 electron and go to cathodic region and add with half of oxygen and water and make 2OH negative ions. And this 2OH negative ion add with Fe2 positive make rust. And then next slide is factor affecting the corrosion of steel in concrete. There are many factors which affect the steel. First one is quality of concrete. As we all know, concrete consists of coarse aggregate, fine aggregate, and cement and water. And when we add right quality of material with proper water cement ratio and correct mixing with proper curing, give a good concrete. But if we don't follow these steps, at last there is a chances of corrosion of reinforcement. Then cover thickness of concrete reinforcement. Cover thickness reinforcement is reinforcement is mostly protected by concrete. If we provide more concrete covering, our reinforcement will protect it from external environment, and our corrosion will our bar is also protected from that environment. Now, third one is condition of reinforcement. If we use reinforcement is contaminated with salt, badly corroded at the time of its placing, it will affect the corrosion rate also. Our steel, it will affect our steel and also increase the corrosion rate. And then effect of environment and other chemical. If we built our structure at that place where rain is mostly happen, so then the chances of corrosion increase. And porosity of concrete. Porosity is if the age of concrete, degree of compression increase. uh, Sorry, if pores are present in the concrete, the chances of water penetration, aggressive chemical more, and that will also affect our steel and increase the corrosion rate. And effect of high thermal stresses. If the deterioration of concrete start, mm, because our normal concrete stand at the temperature up to 100 degrees Celsius, but beyond that, the deterioration, our concrete deteriorate, and due to the deterioration, concretes are consequently affected by environment, and that will also affect our steel. uh, Freezing and thawing condition. As we all know, in cold region, the moisture in the pores of concrete freeze, and due to this freeziness, the ice formation rise, and volumetric expansion may happen, and which may excess the pressure of surrounding concrete mass, at last result in development cracks and also lead to corrosion. Then types of corrosion. First one is uniform corrosion, and then localized corrosion. As you see in figure number 2 and figure number 3, uniform corrosion, which approximately same rate over the exposed metal surface, whereas localized corrosion may affect only one point. Uh, then method for detecting corrosion rate: destructive and non-destructive. It is destructive with the help of DPA, which detect damage in structure in which the test specimen is checked out for damage is totally destroyed in the process of testing. Whereas in non-destructive technique, whereas in non-destructive technique, no wastage of we can get the properties of material and its damage without cause any structural damage and specimen damage. Then then the difference between destructive and non-destructive testing for corrosion in concrete. Then first one is destructive and then non-destructive technique. In destructive technique, while we're doing the destructive testing, the breaking of concrete is necessary. Whereas in non-destructive technique, the breaking of concrete is not required. The real-time mounting is usually performed mostly in destructive testing, and real-time monitoring can be performed with accuracy in non-destructive testing. More wastage of concrete take place in destructive testing, whereas non-destructive no physical damage, hence no wastage. Even through destructive testing is causing wastage of concrete, it is considered as more economical. Why? We can do because we can do destructive method for structure which is not very much important, whereas non-destructive technique are expensive because it is carried out for multi-story building. And types of non-destructive method, first one is acoustic method, and second one is electromechanical impedance technique. In acoustic emission method, it is a non-destructive method. It detect damage in metal, wood, etc. And damage may happen due to temperature, pressure, or leakage. When cracks happen, it generates some elastic waves, and that wave can be detected by acoustic sensor, and which and and indicate and go to that results go to monitor system. And last second one is electromechanical impedance technique. it is a very it is a very powerful technique in which we are using piezoelectric sensor mostly, and it is very and EMI provide much greater information and can be utilized mostly in real life sector and good for long-term monitoring. Now, sensor. What is sensor? Sensor is an electronic device that can measure a physical quantity and converts into a signal which can be read by our instrument and also our observer. And why the corrosion monitoring why we use sensor for corrosion monitoring, mostly for early warning and control, to a reduction in maintenance and minimize the construction installation cost, extend the life of offshore structures. And the types of structure, first one is wireless sensor and then piezoelectric sensor. The sensor networks are highly distributed, highly nodes, which wireless sensor mostly detect the temperature, sounds, vibration, pressure, such as motions or system. Piezoelectric sensor is a device that we can use to measure the changes in pressure, acceleration, and forces by converting them into electrical charges. And these are my literature review. First one is Dami AI et al. In this paper, we revised the comparison of RMST index for both surface bonded and embedded piezoelectric sensor. In this paper, he has taken 3 piezoelectric sensor, as you can see in the diagram, figure number 5. For knowing the process, total 4 cases at different location have been taken, and have been taken for knowing the process. Total 4 cases at different location have been taken for embedded piezoelectric sensor and surface bonding. The piezoelectric sensor of RMST value increased gradually, as you can see in figure number 6, and then see in figure number 7. During the process in surface bonding piezoelectric sensor, the RMST value decreases gradually. Thus, we found that the embedded piezoelectric sensor can effectively filter out the impact effect in structural damage and indication and quantification accurately. Then next one is C. Bharti Priya. In this paper, concrete beam embedded with 6 piezoelectric sensor and were investigated, and RMST value were investigated at different frequency range for 2 to 28, and RMST value for patches for good cure side we compared with bad cure side, and patch second was discarded due to irregular values, and patch 57537 situated on good girl side, and 46 are situated on bad girl side. From it was clear that the good girl side has higher MST value than the bad girl side. Then last one is XU Dongyu et al. In this paper, piezoelectric sensor embedded inside the mixture of cement powder and polymer to find out the effect of temperature and compressive load on a conductance spectra. And figure number 8 shows the value of conductance spectra at different frequency range on various temperature. And figure number 8 shows the conductance spectra value in frequency range 40 to 100 kilohertz. Then figure B show 100 to 500 kilohertz, and then C show 600 to 15 kilohertz at various temperature. And after the RMST index of a piezoelectric sensor at external load at selected frequency were observed, and it was found that RMST index in conductance spectra were loaded in conductor spectra differ with increase the frequency, which is caused by the parallel capacitance in equivalent circuit of sensor. It was found that the larger the temperature deviates the reference baseline, and the larger the RMST variations. And the result shows that the baseline of conductance spectra shifts with increase the temperature, and resonance peaks in the conductor spectra shows obvious temperature dependence results. And these are the conclusion. And the review was carried out to find the utilization of piezoelectric sensor to carry out the corrosion monitoring of steel structure. The following conclusion have been made from the research reviews. RMST was the most suitable damage to monitor the damage in structure, and conductance variance is most likely factor to find out the information at different PZT patches. And also it can be concluded that RMST calculated with value obtained using impedance analyzer is efficient to find out the destructive value. And also it was reviewed through research paper that impact effect is filtered more efficiently when integrated at PZT than when integrated on the surface. These are my references, and thank you. Hello, sir.
Thank you, Ms. Aishwarya. Your presentation was insightful. I would like to ask the members in the audience to please ask if they have any questions. Please ask Ms. Aishwarya their questions.
Aishwarya, I have one question.
Yes.
In your title, it was the review of non-destructive testing.
Yes, sir.
Right, but at the end of your presentation, in conclusion, you are mentioning only about piezoelectric sensors.
Yeah. Yes, sir. Actually, sir, I'm work on piezoelectric sensor. That's why I'm mentioning that only. Yes, sir.
Okay, no issue. Thank you.
Yes.
Okay, Aishwarya ji, thank you very much.
Okay, thank you, sir.
With this presentation. We have one more presentation, but I don't see the authors present here. So if because they are not present, we will just leave the topic to be, and if they probably because of some network issue they are not able to come, so if they join tomorrow we will have their presentation in our sessions tomorrow. And with that, I would like to hand over to Dr. Pankaj to please conclude today's sessions. Thank you.
Thank you everyone for giving this some insightful idea about some recent techniques and some recent advancement in especially in civil engineering, whether it is related to structure, material or construction techniques. And some of the presentation was really very good, especially uh, during one presentation the Vivakars present from raw material to a finished product. It was very wonderful because we can say it is a complete kind of study. And so, apart from that, in other studies also we got so so many outputs. That is all from my side. Once again, thank you everyone.
So with Dr. Pankaj's words, we will conclude today's session. I hope we'll see you all tomorrow as well in different sessions. Thank you very much to everyone who attended us. Thank you for being there.
Thank you, sir. Thank you, Pankaj sir.
Okay then, Arnav sir, shall we finish?
डॉक्टर पंकज आपसे बात होती है बाद में. थैंक यू. बाय बाय.
Okay, bye.